New video. Today we are going to discuss DFA model X, start and contain strings 11 and DFA model 12, 13 and 14. So these are some advanced level DFA construction, right? So let's see what this topic has to offer to us. First step, focus on minimum string. Always satisfy first. Focus on minimum. What the fuck is that? Minimum string. Right. And second step is cover missing transactions to make CO language to make DFA. So from language see the missing transactions, right? Then add some states or transaction rule, right? According to the language. So let's see model X. What is it has to say over that model X language is L and A plus B. So in this, what is this? That it should start with A and A plus B, whatever this is. So minimum string it will generate is equal to A. So first satisfy A here. Alright, this is initial. If it contain A, then it goes to final. Alright. If whatever now it is go A comma B. Alright. If it is start with B, go to trap state. Alright. So this is how this is very simple. Minimum string is A, and for to satisfy this we need three states, one for dead state and magnitude of A and plus 1. We saw this formula earlier. Alright, so what is L? L is equal to B A plus B asterisk. This is a language, it start with B, so same as the previous example. This is it start at least minimum string is triple A. So first satisfy triple A, alright. A, and then A if this it satisfies A, whatever it comes here, A comma B. If whenever B come go to trap state, alright. So this is the main goal. A plus B middle it should contain A at least. So minimum string is A. Minimum string is A. So set first satisfy minimum string, alright. Minimum string. Now see the language. What the language say? Before A, what can come? Anything can come. Alright. So A comma B. Alright. But this is DFA, so we will not do this. We will do this, and again if it contains A, then A comma B here. Yeah. Minimum is A plus 1. Two states are required because there is no dead state here. No dead state required. Right? Yeah. So this is the language. It should contain triple A. Alright. So minimum string is triple A. So how do we do that? First satisfy triple A. Alright. Triple A. It is final. The fuck. Alright. So this is final. So now what we will do is if what the language do, because if it should contain regular A's, all right? So if here is this, there is B, all right? If it contains A, so if it again goes for B, B will go here, all right? If it again goes for B, we will go here. If it again goes for B, we will come here, all right? If the regular A's are consecutive A's are here, then we will accept the string, all right? So this is the case. Minimum triple A, so there is no restraints. Minimum length is equal to 3 plus 1 is equal to 4 states are required. I am waiting A. State I am waiting for A. Yes, wait, transact. I am waiting for a double A. If B again after A, it receive A, then it will transact double A. It received. I am waiting for triple A. Now double A, then this wait. A B A belongs to L. A B belongs to L. So past, present, future, final. So let's say this is initial state. If we have A, B, PPF, minimum future, past, PM, present, future. So how does this making sense? Past, present, future. So how do we do that? A B is past. Now present is B. So this goes to trap state, I think. Future is minimum future. Start and contain. Dead state required. Alright. If it start with anything, dead state is required exactly or at most. And if the end or contain things are happened, then dead state not required at least. So this is at most what is the at most number of states. In this at least number of states are required. Right? So yes, this is it ends with A. So this end with A, this does not require any dead state. So minimum length is A. Alright. So first satisfy minimum length. Alright. If it is here B is, if contains A here, if B from here, it will go to dead state. Right? So where it will do? It will go no. If it require B, if it goes to, it will go to here on B. Right? So this is not goes to dead state, it goes to here. So yeah, there is no number of states. Plus one is equal to 2 states. Alright. There is no need of dead state in this case. Alright. So this is the language A comma B. So it should end with A comma B, alright? So how do we do that? So minimum string is AB. So first satisfy this. A, if it is B, then this is final. Alright? If it again contain A, then here. If uh, if how we do waiting for AB? What waiting for AB? Number one, waiting for AB. Yes, get is B. Number two, waiting for B. Yes, exactly ends with AB final. So if here A, if here comes B, then where we will go is we go for because any string can come, so we go for non final state. So if B then A then B, so add B here, and from here if we receive A, so we will jump on that only. Yeah, where 2 plus 1 3 states are required. Waiting for What the present, past, future case? I don't think I'm receiving this. AB 3, alright. A. What is A here? A final, ABA belongs to L, ABA, ABA, B belongs to L. So this is all the cases. Ends with A, first satisfy this, and this, all these things are happening. What is this? What is minimum string? This is an interesting case. So minimum string it can generate is AA or BB. So it should first satisfy these minimum cases. Now let's say A, and this is A. All right. If it is B, again B. So this goes to here. If. So it should start with A, and B. If it should start with A, and if it after A, if it contains B, the set should be dead state. Yeah, it is a at B, at A, B. If it is contained here, A, B here. So when we uh, when we're doing the case of start with, then we need ready state. So minimum length 1 plus 1, 1, 2, 2 plus 2, 4 plus 1, 5 states. So these are some cases. What is this string? This is A plus B contains. So name string is what will do this. A, A, B, B, and if it is A, what is here? It is A, and if it should contain A and B, na? So then what we can do? So first of all, do this first. What if it contains B here? So we will go here. It contains here A. So A, B, B. Then we can do A. This is a case here. This is a perfect example. Yeah. So what is this? LA plus B, A plus B. So how will be minimum is A and BB? And what will be done that here? This if is A, then B, A, then B here, then B here. Yeah, this is a perfect case. Yeah. Model 11. What this model 11 teaches us is that multiple conditions remainders. All right. So how will we do that? And there is a W string which belongs to this. Number of A's is divisible by 2 and number of B's divided by 2. So how can we do that? This is also the case number of A's W divisible by 2 and number of B's. Or this is the end case and this is the OR case. So divisible by 2 and or but not divisible by 3. So these are what the forest states. So how can we do that? Four states are required. 2 into 3, 2 into 2 equal to 4 states in these cases, 2 and 2 and or in and around cases, alright, but not. So in this case 2 into 3 equal to 6 states are required. So let's see what the example say that. So if A0 B0 is final, then A is even and B is even. If A1 is odd, A1 B0 is final, then what we do that? First case. What was the first case? number of A's and number of B's divided by 2. Alright, so how we'll do that? What are the possibilities of A's and B's? Minimum would be A0, B0, A1, B1, A0, B2, B0, A0, B1, A1, B1, A2, B2. Alright, so how will initial state is the number of A0, B0 is if we get 1A, alright, so we go A B0. If we get 1 B from here, we go A1 B1. If we get 1 B from here, so we go A0 B1, alright, B here. If we get what 1 A from here, so 1 A from here, alright. So what is the case? We have here more states are required, I think. 2 AR. We get A1 B0. We can get A0 B0. If from here, if we get A again, so we go to here final. This is the final. Alright. End case. And from here, and again B, go to final. So what is the case is? Even if we get A here from here, we go for A. Right? Get B from here, so B will be 0. Remainder 0. Alright? 1, 2. How we do that? 1A, B, 1A and B. So these are, yeah, this is the case. These are correct. This is a very beautiful example. Alright, remember it. And this is the beautiful case for doing problems. Alright. So what we are going to do here is also there is a string W. Alright. Alright. So number of A's in W is divisible by 2 and number of B's in W is divisible by 3. So what is the remainder? 0, 1, 2 and 0, 1. So what are the possible state? A0, B0, A0, B1, A0, B2, A1, B0, A1, B1, A1, B2. These are the possible states. So what is the if we get from here A1, alright, so we go for A1, B0. If again we get A, so where we go is remainder case A. If we get from B here, from here, we go A1, B1. Right? We get B from here, we go to A0, B1. If we get again from here A from here, so where we go is this A1, B1. No, we go for this. For A. For B, where we will go? A0 B2 for B. Alright, for A, where will we go is if from here I get what? B. So where will we go is where will we go? End case. This is the end case, no? So B and again if we get B, then A. So we will go for A0 B0 case. But this is the end case, no? Yeah, we go for B here. But the zero case is also the remainder case, yes. So this is how we do it. B. And if we get A from here, so where will A1, B2, A1, B2 here, A1, B2. So in the case of B, we get from here what? A. So where will we go? A0, B1. At A from here, A0, B1. Right. It's the case where if we got B here from here, what we get if A1 is here? Here B2, if we get A from here, what we will do is A0, B2, yeah. A0, B2 is the case. In the case of A, but in the case of B, in the case of B will be where we go A1 B0. So where is A1 B0? Here. So this is the case. Very interesting case here. So number of states 1, 2, 3, 4, 5, 6. 2 and 2, 3 equal to 6 states. A0 B1, I think. A0 B1. This is the final state. What is the final state? B1. This is the final. What is the final state was? A B B. A1 B1. Is this the final? If we get A, then we go A1 B0. If you get B, A1 B1, yeah. And what is the case? How we can go through finally here? A and B. This is the final state. What was the case from here? This is the case, alright. So this is the final state, I think. Yeah. And what is in this case? First case, method 1. First, second, 4. The 12 position case. What the fuck is going on here? First, A not equal to 1 and so is not equal to 0. Not divided by 3. So these are the cases. Let's see what is going to be. So what is A modulo 2? Well, A modulo 2 is equal to 1, right? What does that mean is it should be odd, yeah. And modulo 3 is equal, not equal to 0. Not equal to 0. What are the cases? Cases are same here. The case is finally solved. So A0, if we get A, then A, B here, it goes here. What was the final? B1. These are the remainder, so I think, yeah. B1 here, and B2, I think A1, 1, yeah. These are the two final states. A0, B0 is the final state. No, no. Second case, equal to 0, A0, B0, final A0, B1 equal to final, B2 final. Number 8, A0, B0, 5. B0, or in the case of or A0, B1 is also B2 and A1, B0. Yeah, this is the case. If node number B divided by 3 is final, yeah, this is the case. Yeah. So number of edge divided by 2, and this is the already case I have covered. I think, yeah. Your cases are covered by me. Metal 12 is, what is metal 12? Position based. Number of A, second symbol of W is A, third symbol of A, from W from AND is A. These are some cases. From AND cases is important. We see in the next lecture for this. So till then, take care, God. Bye bye. Thank you so much for watching the video.